We are developing a computational model for human neural tube closure. With this model, we think we can improve the prediction of human developmental toxicity.
In order to improve human chemical and pharmaceutical safety assessment, we need a fresh look at the way we work. The classical way of safety assessment relies heavily on the use of laboratory animals, assuming that they were miniature human beings. However, humans may respond differently to toxic substances than animals.
We believe that toxicity testing should be improved to achieve a better risk assessment in humans. We can do that by combining human data with new in silico as well as in vitro tools to get a complete picture of the toxicity of chemicals.
RIVM is working on a new approach for human safety assessment based on ontologies. Ontologies describe the biology of human physiology and disease, starting at the level of genes and molecules.
Based on our knowledge of physiology and disease, we can actually describe what happens when a compound affects the system all the way until the disease that emerges at the end. We can describe this process in so-called adverse outcome pathways, in which we describe all the different elements that lead from the initial event to the adverse outcome in the end. In order to build ontologies, we need extensive data mining. The data mining will help us to delineate the AOPs, starting from the exposure situation to the disease state. And within the ontologies and within the AOPs, we will then be able to define what are the critical points that we need to address in terms of a testing system. So we will design a battery of test systems that take care of all these different points, and then with an in silico model we will translate the results of these in vitro models into a prediction of toxicity. Using AOPs, we will be able to understand how neural tube effects come about and how compounds affect the system.
One of the most prominent neural tube-related malformations in human embryos is spina bifida. Using the ontology approach, RIVM is working on a three-dimensional computer model of neural tube closure in the developing embryo.
We have a detailed understanding of how the neural tube is formed in embryogenesis. This allows us to describe the ontology, to extract the AOPs, and to define what test systems we need to test the effects of compounds on the system. And this, combined with in silico models, will allow us to do a hazard and risk assessment of chemicals using this novel human-based system.